High fidelity, or hi-fi reproduction is a term used by home stereo listeners and home audio enthusiasts to refer to high-quality reproduction of sound to distinguish it from the poorer quality sound produced by inexpensive audio equipment, or the inferior quality of sound reproduction that can be heard in recordings made until the late 1940s. Ideally, high-fidelity equipment has minimal amounts of noise and distortion and an accurate frequency response. History. Bell Laboratories began experimenting with wider range of recording techniques in the early 1930s. Performances by Leopold Stokowski and the Philadelphia Orchestra were recorded in 1931 and 1932 using telephone lines between the Academy of Music in Philadelphia and the labs in New Jersey. Some multi-track recordings were made on optical sound film, which led to new advances used primarily by MGM and 20th Century Fox. RCA Victor began recording performances by several orchestras on optical sound around 1941, resulting in higher fidelity masters for 78 RPM discs. Also during the 1930s, Avery Fisher, an amateur violinist, began experimenting with audio design and acoustics. He wanted to make a radio that would sound like he was listening to a live orchestra, that would achieve high fidelity to the original sound. Beginning in 1948, several innovations created the conditions for a major improvement of home audio quality. Reel-to-reel audio tape recording, based on technology taken from Germany after the war, helped musical artists such as Bing Crosby make and distribute recordings with better fidelity. The advent of the 33 1/3 revolutions per minute long-play microgroove vinyl record, with lower surface noise and quantitatively specified equalization curves as well as noise reduction and dynamic range systems. Classical music fans, who were opinion leaders in the audio market, quickly adopted LPs because, unlike with older records, most classical works would fit on a single LP. FM radio, with wider audio bandwidth and less susceptibility to signal interference and fading than AM radio, though AM could be heard at longer distances at night. Better amplifier designs, with more attention to frequency response and much higher power output capability, reproducing audio without perceptible distortion. In the 1950s, audio manufacturers employed the phrase high fidelity as a marketing term to describe records and equipment intended to provide faithful sound reproduction, while some consumers simply interpreted high fidelity as fancy and expensive equipment. Many found the difference in quality between hi-fi and the then standard AM radios and 78 revolutions per minute records readily apparent and bought 33 1/3 LPs such as RCA's New Orthophonics and London's FFRR, and high-fidelity phonographs. Audiophiles paid attention to technical characteristics and bought individual components, such as separate turntables, radio tuners, preamplifiers, power amplifiers and loudspeakers. Some enthusiasts assembled their own loudspeaker systems. In the 1950s, hi-fi became a generic term, to some extent displacing phonograph and record player. In the late 1950s and early 1960s, the development of the Westrex single-groove stereophonic record cutter had led to the next wave of home audio improvement, and in common parlance, stereo displaced hi-fi. Records were now played on a stereo. In the world of the audiophile, however, high fidelity continued and continues to refer to the goal of highly accurate sound reproduction and to the technological resources available for approaching that goal. This period is most widely regarded as the golden age of hi-fi, when tube equipment manufacturers of the time produced many models considered endearing by modern audiophiles. and just before solid-state equipment was introduced to the market, subsequently replacing tube equipment as mainstream. A popular type of system for reproducing music beginning in the 1970s was the integrated music center, which combined phonograph, radio tuner, tape player, preamp, and power amplifier in one package, often sold with its own separate, detachable or integrated speakers. These systems advertised their simplicity. The consumer did not have to select and assemble individual components. Purists generally avoid referring to these systems as high fidelity, though some are capable of very good quality sound reproduction. Listening tests. Blind tests refer to experiments where researchers can see the components under test, but not individuals undergoing the experiments. In a double-blind experiment, neither the individuals nor the researchers know who belongs to the control group and the experimental group. Only after all the data has been recorded do the researchers learn which individuals are which. A commonly used variant of this test is the Abx test. A subject is presented with two known samples, and one unknown sample X, for 3 samples total. X is randomly selected from A and B, and the subject identifies X as being either A or B. Although there is no way to prove that a certain lossy methodology is transparent, a properly conducted double-blind test can prove that a lossy method is not transparent. Scientific double-blind tests are sometimes used as part of attempts to ascertain whether certain audio components have any subjectively perceivable effect on sound quality. Data gleaned from these double-blind tests is not accepted by some audiophile magazines such as Stereophile and the Absolute Sound in their evaluations of audio equipment. John Atkinson, current editor of Stereophile, stated that he once purchased a solid-state amplifier, the Quad 405, in 1978 after blind tests, but came to realize months later that the magic was gone, until he replaced it with a tube amp. Robert Harley of the Absolute Sound wrote, in a 2008 editorial, that blind listening tests fundamentally distort the listening process and are worthless in determining the audibility of a certain phenomenon. Doug Schneider, editor of the online Sound Stage Network, refuted this position with 2 editorials in 2009. He stated, blind tests are at the core of the decades worth of research into loudspeaker design done at Canada's National Research Council. The NRC researchers knew that for their result to be credible within the scientific community and to have the most meaningful results, they had to eliminate bias, and blind testing was the only way to do so. Many Canadian companies such as Axiom Energy, Mirage, Paradigm, PSB and Revel use blind testing extensively in designing their loudspeakers. Many audio professionals like Sean Olive of Harman International share this view. Semblance of realism. Stereophonic sound provided a partial solution to the problem of creating some semblance of the illusion of live orchestral performers by creating the phantom middle channel when the listener sits exactly in the middle of the 2 front loudspeakers. When the listener moves slightly to the side, however, this phantom channel disappears or is greatly reduced. An attempt to provide for the reproduction of the reverberation was tried in the 1970s through quadraphonic sound, but, again, the technology at that time was insufficient for the task. Consumers did not want to pay the additional costs and space required for the marginal improvements in realism. With the rise in popularity of home theater, however, multi-channel playback systems became affordable, and many consumers were willing to tolerate the 6 to 8 channels required in a home theater. The advances made in signal processes to synthesize an approximation of a good concert hall can now provide a somewhat more realistic illusion of listening in a concert hall. In addition to spatial realism, the playback of music must be subjectively free from noise to achieve realism. The compact disc provides about 90 decibels of dynamic range, which exceeds the 80 decibels dynamic range of music as normally perceived in a concert hall. Audio equipment must be able to reproduce frequencies high enough and low enough to be realistic. The human hearing range, for healthy young persons, is 20 Hz to 20,000 Hz. Most adults can't hear higher than 15 kHz. CDs are capable of reproducing frequencies as low as 10 Hz and as high as 22.05 kHz, making them adequate for reproducing the frequency range that most humans can hear. The equipment must also provide no noticeable distortion of the signal or emphasis of any frequency in this frequency range. Modularity. Integrated, mini, or lifestyle systems, also known as music centers or mini-systems, contain one or more sources such as a CD player, a tuner, or a cassette deck together with a preamplifier and a power amplifier in one box. Although some high-end manufacturers do produce integrated systems, such products are generally disparaged by audiophiles who prefer to build a system from separates, often with each item from a different manufacturer specializing in a particular component. This provides the most flexibility for piece-by-piece upgrades and repairs. For slightly less flexibility and upgrades, a preamplifier and a power amplifier in one box is called an integrated amplifier, with a tuner. It is a receiver. A monophonic power amplifier, which is called a monoblock, is often used for powering a subwoofer. Other modules in the system may include components like cartridges, tone arms, hi-fi turntables, digital media players, digital audio players, DVD players that play a wide variety of discs including CDs, CD recorders, mini-disc recorders, hi-fi video cassette recorders and reel-to-reel tape recorders. Signal modification equipment can include equalizers and signal processors. This modularity allows the enthusiast to spend as little or as much as they want on a component that suits their specific needs. In a system built from separates, sometimes a failure on one component still allows partial use of the rest of the system. A repair of an integrated system, though, means complete lack of use of the system. Another advantage of modularity is the ability to spend money on only a few core components at first and then later add additional components to the system. Some of the disadvantages of this approach are increased cost, complexity, and space required for the components. Modern equipment. Modern hi-fi equipment can include signal sources such as digital audio tape, digital audio broadcasting, or HD radio tuners. Some modern hi-fi equipment can be digitally connected using fiber optic Toslink cables, universal serial bus ports, or Wi-Fi support. Another modern component is the music server, consisting of one or more computer hard drives that hold music in the form of computer files. When the music is stored in an audio file format that is lossless, such as FLAC, Monkeys Audio, or WMA lossless, the computer playback of recorded audio can serve as an audiophile quality source for a hi-fi system.